Welcome to our comprehensive guide to the essential formulas of calculus. In this video, we'll cover the fundamental formulas for both differentiation and integration, which form the backbone of calculus. Let's begin with differentiation formulas. Differentiation is the process of finding the rate of change or the slope of a function. First, let's look at the basic differentiation rules. The derivative of a constant is 0. The derivative of x to the power of n is n times x to the power of n minus 1. These form the foundation of differentiation. Next, we have the rules for differentiating combinations of functions. The sum rule states that the derivative of a sum is the sum of the derivatives. The product rule is used when differentiating the product of two functions. And the quotient rule is used when differentiating the quotient of two functions. The chain rule is arguably one of the most important differentiation rules used when differentiating composite functions. It states that if y equals f of g of x, then the derivative of y with respect to x equals the derivative of f with respect to g times the derivative of g with respect to x. Let's now look at the derivatives of common functions. The derivative of sine of x is cosine of x. The derivative of cosine of x is negative sine of x. The derivative of tangent of x is secant squared of x. The derivative of e to the power of x is e to the power of x. The derivative of the natural logarithm of x is 1 over x. Now, let's move on to integration formulas. Integration is the process of finding the accumulation of quantities or the area under a curve. First, let's look at the basic integration rules. The integral of a constant c is c times x plus a constant of integration c. The integral of x to the power of n is x to the power of n plus 1 divided by n plus 1 plus a constant of integration c, where n is not equal to negative 1. Integration by parts is a technique used to integrate products of functions. It's derived from the product rule of differentiation and is expressed as the integral of u times dv equals u times v minus the integral of v times du. Integration by substitution is another important technique based on the chain rule of differentiation. It involves substituting a new variable to simplify the integral. Now, let's look at the integrals of common functions. The integral of sine of x is negative cosine of x plus a constant c. The integral of cosine of x is sine of x plus a constant c. The integral of secant squared of x is tangent of x plus a constant c. The integral of e to the power of x is e to the power of x plus a constant c. The integral of 1 over x is the natural logarithm of the absolute value of x plus a constant c. Finally, let's discuss definite integrals. A definite integral represents the exact area under a curve between 2 points. The definite integral of a function f from a to b is calculated by evaluating the antiderivative f at the upper limit b and subtracting the value of the antiderivative at the lower limit a. And there you have it, the essential formulas for differentiation and integration. These formulas serve as the foundation for calculus and have applications in various fields such as physics, engineering, economics, and more. Keep this video handy as a reference when working on calculus problems. Thank you for watching. If you found this summary helpful, please consider liking and subscribing for more math tutorials.